Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about how we're going to construct through graphs and tables by taking an application. In this video, I'm going to cover it. So before going to see that, we have to see some little bit information about how we're going to organize and presenting the data graphically. So for that, so the data normally should be in raw form and usually not too easy to use to make some decision making. So for that, what you have to do is, so how two types of organizations can be made. So first thing is that the table, and second one is that through graphs. So what are the various techniques that can be involved for implementing this decision making techniques? So for that, so first one is the ordered array, and another one is that stem and leaf display, and next one is the frequency distributions and histograms, and next one is the bar charts and pie charts, and last another thing is that contingency tables. Okay, so these are the some of the techniques that may be useful to apply on the raw data form. So normally this numerical data is going to be classified into two types. So first thing is that ordered array, and another thing is that frequency distributions and cumulative distributions. So if I'm going to consider this ordered array, I can able to implement this through the stem and leaf display technique, whereas this frequency distributions and cumulative distributions, I can able to implement this through histogram or either through polygon or through the okay. Okay, so the numerical data whatever we are having, so that can be implemented through the techniques like ordered array and then frequency distribution, cumulative distributions. So within that ordered array, that one thing it can be implemented through the technique what you can able to call it as a stem and leaf display, and the frequency distributions or cumulative distribution that can be implemented through the techniques like histogram, polygon, and okay. Ordered array. So ordered array is nothing but a sorted list of the data where it can able to shows the range in between minimum to maximum, and should also provide some signals about the variability within the range, and it may also help to identify the outliers what we call. So this outlier normally you can able to call it as unusual observations. So if the data set is large, then the ordered array is the thing which should be less useful. So ordered array is nothing but it is one kind of sorted list of data, and which can able to shows the range in between some minimum to maximum value, and where can also implement some of the signals about the variability within the range, and should also helpful in identifying the errors, outliers. That is nothing but unusual observations. And if the data set is not large, then what will happen? This ordered array is less useful. That is the disadvantage of this one. So let's take an example. So the data what we collected should be in raw form. That should be as in this form actually. Then what we have to do? We have to make this the data in ordered array from smallest to largest one. So what is the data we collected? That should be converted into ordered array. That should be arranging the data either in smallest to the largest value. And stem leaf diagram is another kind of technique where you can able to implement it. So it is the simple way to see the distribution in details in the data set. And method is that we have to separate the sorted data series into the leading digits, what we call it as a stem, and the trailing digit, what we call it as leaves. Right. So the techniques what we are having, so that is the stem and leaf diagram. So this diagram able to separate this sorted data series into two phases. So one is through leading phase and another is through trailing phase. So the leading thing digits what we call it as a stem, and trailing digits what we call it as leaves. So next, suppose initially we have this data, right? So this is the data. Initially, the first step, and then second thing is that we have to sort this into sorted order. Once that one is done, so let's take this values like 21. Suppose here I'm going to use the 10 digit as the for the stem unit for that. So the 21 I'm taking. So that's 21. How can I able to represent it as? So the 2 should be the stem and 1 should be the leaf here. And similarly for 38, 3 I can able to represent it as stem and 8 it should be represented as leaf. Right? Suppose if I'm going to represent 41, suppose for how the 41 is going to be represented. So 4 and then 1. The stem is 4 and the leaf should be 1. Similarly, if I'm going to take 32, so 3 like this, I can able to represent it. So after that, next, suppose the complete leaf diagram, how can I able to represent it? Suppose if I'm going to take the stem 2 here, so after identifying this data, so the 2 is the value which should be called as stem. So for the 2, what are the values having? 1, 4 and 4, 6, 7, 7, 6, 7, 7. Similarly, if I'm going to take 3 as stem, so what are the leaves here? So 0, 2 and 8. So 0, 2, 8. And 4 if I'm going to take, so 1. Right? So like this, I can able to construct this stem leaf diagram from the data. And next thing is that suppose how we're going to construct these 100 digits as the stem. So for that, what I have to do is how to round off to the 10 digits. So for that, what you have to do? So 613 should become 6 has become as the stem and leaf should become as 1 here. If I'm going to take 10 digit number. Similarly, if I'm going to take 7 and the leaf should become as rounded off. And similarly, if I'm going to take 12, 2 should be the leaf. So like this I can able to construct by if I'm going to round out the 10 digit number. Similarly, if I'm going to use 100 digit as the stem means, so how can I able to represent it? So 6 is the stems, another is 7 and 8, 9, 10 and 11, 12. So this becomes the stem and leaf should be 1 and then 3 and then 6, or I can able to take 5. And similarly, next one is that 8, 7. So what are the stems here? I can able to take 2 and then this should be rounded off 2 and 5 and then 8. Similarly, if I am going to take 8, so what are the stems will be? 3, 4, 5, 6, 9, like this I can able to construct it. And next thing is that tabulating numerical data. For that is frequency distribution. So what is the frequency distribution here is, frequency distribution is the list or a table and containing class groups which can able to categorize or ranges within the data falls actually, and the corresponding frequencies within which the data fall within the each grouping or category. Right? So the frequency distribution. So the frequency distribution is a list or it may be a table which is going to be containing or categorizing various groups like class groups and corresponding frequencies groups. So the frequency distribution is the way to summarize the data, and then this distribution condenses the raw data into more useful form, and it should also allows for a quick visual representation of the data here. Right? So the frequency distribution is the way to summarize the data, and then this frequency distribution condenses the raw data into more useful form and also allows for the quick visual interpretation of the data. Class intervals and class boundaries. So each class groups have same width, and then the determining the width of each interval should be calculated through by the equation like the range should be divided with the number of desired class groupings, and use at least only 5 but not more than 15 groupings is the thing, and class boundaries never overlap, and round up of the interval width to get the desirable endpoints is the thing. Okay, so each class group would have the same thing, same width, and determine the width by using the formula like range divided by number of desired class groupings, and use at least 5 but not more than 15 groupings should be considered, and the class boundary should never overlap. So let's take an example, right? A manufacturer of insulation so randomly selects 20 winter days and records daily high temperature. Right? So the manufacturing of insulation department is going to be collected some 20 winter days. So what should be the daily high temperature like this. So these are the 20 days data what I have. So one day it should be 24, 35, 70 like this. So for this, what you have to do is, so first thing is that we have to sort the data into ascending order. Then once the data is going to be sorted, then we have to find the range. So 58 is the highest value and the lowest is 12. So we have to subtract this and then we have to get the range here. Then select the number of classes, how many it will be. So usually it should be between 5 and 15. So I'm taking it as 5 and compute the class interval width. So how it should be done? So 46 is the value range divided by 5 I'm taking. So that should be 10. That should be rounded off to 10. So 9.5 something like this. And determine the class boundaries limit, that should be 10, 20, 30, 40 like this, 60. And then compute the midpoints. The midpoint will be in between these two values. So let it be 13, 15, 25, 35, 45 and 55. And then count the observation and assign to the classes, right? So these are the steps what have to be followed. So once the data we get from the any other company, so first what you have to do is we have to sort the data first in ascending order and find the range. So subtract from highest value to the lowest value and find out the number of classes. Number of classes that should be lies between 5 to 15. Either you can able to take 10 also, but I'm taking here as 5. So compute this the width of this class interval. So how it will be means the 10 divided 46 divided by 5, so 9 point something, that should be rounded up to 10. And find out this class boundary limit, that should be 10, 20, 30, 40 and 60. And compute the class midpoints. So in between midpoints what it is, so in between 10 and 25, so 15 is the thing, and 20 and 25 it should be 25. So count the observation and assign to the classes. And once that thing is done, so what I have to do is, so write down one column as classes, frequency, relative frequency, and then percentage. You have to find it out. So in between 10 and 20 class, so how many number of values are reflected? So in between 10 and 20, so 3 values are reflected. So these 3 I'm taking out. And in between 20 and 30, how many classes are reflected here? 20 and 30. So 1, 2, 3, 4, 5, 6. So 6 values I can able to write here, 6. And in between 30 and 40, 5 values. Sorry, this one will not come. So up to here. And for this one. And similarly 40 and 50, again 4. And 50 to 60, 2. So like this I can able to get the frequency values. So from the relative frequency I can able to get the values like 1.15, 30, 0.25 is the relative frequency, and percentage should be 15, 13, 25. So count this total frequency and relative frequency and then percentage. Then how we're going to graph this numerical data. For that we're having technique like histogram is the thing. So for the histogram, what is the actual histogram? So the graph of the data and frequency distribution called as histogram, and class boundaries or class midpoints are going to be shown it as horizontal axis, and vertical axis can be either frequency I can able to take, or I can able to take relative frequency, or percentage I can able to take. And the bars of appropriate heights are going to use to represent the number of observations within the class here. So once that is, let me show this how to construct this histogram. So this is the data what we're having here. So from this, what we have to do is we have to construct the histogram. So what we have to do here, let's take a horizontal axis and vertical axis. The horizontal axis I'm taking class midpoint, that is 5, 15, 25, 35, and frequency I'm going to take on y-axis. So in between 10 to 15, so in between 10 to 20, right? So what is the 15 is the 3 is the frequency. So I'm going to draw this one. In between 22 and 30, so what is the frequency? 6. So I can able to draw 6 here. and then in between 20 and 30 it should be 5. So like this I can able to construct this histogram without any gaps between the bars. Okay, if there is going to maintain a graphs in between space is going to maintain between the graph, then it should become the bar chart, not the histogram. So how can we can able to construct the histogram in Excel also we have having. So take it as go to Microsoft Excel and then click on tools where you are having the data analysis. Click on this data analysis tool and then select whatever the graph. Select whatever the graph you want. That should be histogram. Choose to and then give the input range of this and then click on the chart output so that what we can able to get the histogram. And next thing is that what are the questions that may be for grouping of data into classes. So some of the questions may ask how wide should each interval will be. So how many classes should be used and how should the endpoints of the intervals can be determined. Like this, suppose the often onset should be by trainer error method, so subjected to the user judgment, and then the goal is to create a distribution that is neither too jagged or neither too blocky, and the goal is to appropriately show the pattern of variation in the data. So these are the some of the questions that may come for grouping of data into classes. So how wide should each interval be? How many classes should be used? And how should the endpoints of intervals can be determined? So often used by the trainer as a subject to user judgment. And then the goal is to create a distribution that is neither too judged or not too blocky. So normally these class intervals would be have different types. Like many, so many means narrow class intervals. So narrow class intervals means which can able to aid a very large distribution with gaps from the empty classes and should also give a pure indication how the frequency varies across the classes. And few means wide class intervals, so which can also compress the variation too much and yields a blocky distribution, and you can also obscure important patterns of the variation, right? So the class intervals will be of two types, so many and few. Narrow, so the width of this each and every bar should be very narrow looks, and wide class intervals, so the width should be very, width of the each bar should be more here, that should be wide class intervals. So normally these class intervals able to yield a very jagged distribution with gaps and then should also give some poor indication for finding the values, and then wide class intervals may compress the variation too much and yield a blocky distribution and can also obscure important patterns of variation. So the class midpoint. So once we get this data, then we have to how to construct the frequency polygon. So normally we are going to construct in between 10 and frequency polygon, right? So for that, what you have to do? So once we construct this histogram, what I constructed previously, right? So same thing I'm going to take here. So for construction of this frequency polygon, so identify the midpoints of each bar diagram. Okay, so once you are going to identify this frequency bar diagram, so try to join all the midpoints of this rectangle bars, then we can able through a straight line, then the curve what we obtain should be the frequency polygon. Okay, so similarly if I'm same thing, if I'm going to join similarly same thing, identify midpoints here, and if I'm going to join these dots by smooth curve, so normally what we can able to call it as frequency curve. Okay, whatever the midpoints of the graph should be joined through a normal freehand curve, that should be frequency curve, and if I'm going to join through a straight line, then it should be a frequency polygon here. That is the difference. So once the histogram is going to be constructed, so that is the way. This is the graph what how I can obtain from the previous example. So next we're going to tabulating the numerical data through cumulative frequency. So up to now, here I have conducted so frequency and percentage I find out. Then how could I find out this cumulative frequency and cumulative percentage? So for that, so what we have to do is we have to cumulative frequency is 3. So 3 you have to take here, and these 3 should be sum up of with the next frequency value, that is 6. So 6 plus 3 how much? Then 9 will come, and 9 plus 5 how much? 14. 14 plus 4 18, and 18 plus 2 20. So this is the cumulative frequency curve. Okay, so what is the frequency I'm having? So if I'm going to get the cumulative frequency, then you have to sum it. So first thing is that 3 here, so 3 take it out, add to the next frequency value, that is 6 plus 3 9, and 9 plus 5 14, 14 plus 4 and 18 plus 2, like this. So how could I obtain this cumulative percentage also here? So for this cumulative percentage, some same thing, same steps I'm going to repeat it. So initially 15 I'm taking, and 15 should be added up with 30, that should become 45, and 45 plus 25 70, 70 plus 20 90, 90 plus 10 100. So like this I can able to get this cumulative frequency and cumulative percentage values. So once that one I think, then I can able to construct this OGIV. OGIV I can able to construct by simply getting the marking the points on the graph and simply join those dots with a straight line here. So what is this value here? So for less than 10, so it should be cumulative percentage 0. So 0, and class boundary is 20. For 20 it should be 15, and for 30 it should be 45, and 40 it should be 70, and 50 it should be 90, and 60 it should be 100. So after joining all these dots through a straight line, then it should becomes the OGIV also. And next thing is that scatter diagram. So scatter diagram is going to be used for bivariant numerical data. So the bivariant data is nothing but it should be consists of some paired observation that is going to be taken from two numerical variables. Okay, so the scatter diagram is the thing which should be bivariant numerical data, which consists of paired observations taken from two numerical variables. So the scatter diagram, so one variable is measured on the vertical axis and another variable is measured on the horizontal axis. So let's take an example here. So volume per day I'm taking one as one column, and cost per day is another column. So how to construct this scatter diagram? So I'm going to take the volume per day onto the x-axis and cost per day onto the y-axis here. So once that thing is done, identify this. So 23, so what is the cost per day? That should be 25 dot, and 26 it should be 140, and 29 should be 140, like this. I have to mark the dots, then it should become the simply scatter diagrams look like this one without any lines and joinings and all, simply dots. How can able to represent it? So how to construct this scatter diagram in Excel? I will show it. So for that, open this window Excel and then go to this bar chart symbol and then select this XY scattered plot. Once that one is selected, then you can able to use either this one. You can choose any type, what kind of scatter diagram plot you want to take it out, and then click on to the next. Right. So like this, I can able to construct this scatter diagrams and all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.